Hello guys, welcome to my YouTube channel. So today we'll be solving Codeforces contest 905. Okay, so before starting, I have just a small announcement for all of you, as many of you guys were reaching out to me for discussion and for interview preparation guidance and resume reviewing. So I decided to make my appointments available on Calendly. Go, feel free to schedule any appointments, and the best part, it's free. Yes, you heard it right, it's totally free. Okay, cool guys, I'll paste the link into the description. Now coming back to the problems, this is the first problem, a morning. Okay, reading the question, what we get to know is there will be a 4-digit passcode, and we have one, let's say kind of timer or display. Yeah, we have display that can display number 1 2 3 4 5 6 7 8 9 10, or 0, sorry, not 10. Now what we need to do is we have to make a pin. So it's better, sorry. So what I was saying is, so we have some kind of pin like 2 3 5 4, and we have a display which can show numbers, some numbers over here, and this number can be 1 2 3 4 5 6 7 8 9 0. Now if we are at 1, and we have to go to 2, we'll have to press it one time. Again from 2 to 3, one more time. 3 to 4, one more time. So from, like, if we want to go from 3 to 4, we can go it one move, but if we want to go to 3 to 6, then we'll have to go to 3 to 4, then 4 to 5, and then 5 to 6. So for going from 3 to 6, we'll need 3 moves. So what it is saying that in one move we can just move to the next adjacent digit, and we can move in both the direction, either in the left, or sorry, either in the right or in the left. That won't be an issue. Now, and if we want to punch a number, or if we want to display the digit, we'll have to press the cursor once. So it's something like that. Let's say if you have some kind of your digital device and you will write some numbers. Okay, so if you want to write something over here, we'll have to press it one time, so that the number displayed over here, let's say if it's x will be printed over here. So now what we need to do is, we'll have one pin, let's say 2 3 5 4, something like that. We have this display, and we have to push up or print this number, and initially the number will be one displayed over here. So from one, what we can do is, first of all we'll be printing 2, then we'll print 3, then we'll print 5, then we'll print 4. The order will be the same. Okay, so first of all, from 1 to, we need to go from 1 to 2, and if we'll see this number chart, or like the list, we need one move, just one move. So what we can do is from 1 to 2 we'll need one move, and then from 2 to 3, and yeah, one move to print it. Okay, now initially we have 1, and now we'll have 2 in our display board, and from we need to print 3. So from 2 to 3 we'll need one more step. Okay, and one more step to print 3, right? And now we are at 3 and we need to print 5, then we will have to move 2 steps, and then one for printing it. Then we are at 5 and we need to move to 4, then we will take one step in the left, that is, that will be equivalent to one press, right? And then one press to print the number. So we can see that this number will always be constant, because we need to print 4 numbers, right? So we need to print 4 numbers, then we'll have to print 4 times, that will take 4 counts, right? Now we can just simply start that initially we are at 1, then we can simply go to 2, we can calculate how many numbers, or like how many steps we can take. So for that, what we can do is, we can store kind of position, that 1 is position 1, 2 it has position 2, till 9 is at position 9, and 0 is at position 10. So whenever let's say if we are 5, and if we want to go to 5, okay, like if we want to go from 1 to 5, then the position of 5 is 5, right? And the position of 1 is 1. So if we will take the absolute distance, that will be the number of times we'll have to press the key. Good. So what we are saying, that for any number, let's say 2731, what we can do is, initially we are at 1, and we know that the position of 1 is 1, and the position of 2 is 2, or it's better to write it 0 over here, so that to have a better clarity. Okay, so if we are at 1, and we already know that there will be 4 press needed to print these 4 numbers. Okay, now apart from that, if we are at 1, we want to go to 2, the absolute difference between them will be 1. Okay, so we can write over here, now we are at 1 2, and from 2 we need to go to 7. For that, we know the difference between their position is, because we know that right from this table or this map, we can say that for the 7 we'll have 7. Only the difference is that for 0 we are having position 10. So for 7 and 2, the absolute difference will be 5. Similarly, for 7 and 3, absolute difference will be 4. And then from 3 to 0, the position of 0 is 10. Remember, position of 0 is 10 and the position of 3 is 3. So the absolute difference will be 7. Okay. So in total, how many steps we are taking? 4 plus 1, 5. 5 plus 5, 10. 14 and 21. So in total, we will be requiring 21 steps. Okay. So now what we can do is, first of all, we can make a map, or however you want to store the values. It's better. We can simply make a map of int comma int. Okay, we can simply make a map of int comma int, and we can store all the values position, or like the position of all the values. So we can simply run a loop for I is equals to 1 2 I less than 9, and we know that in this scenario we can simply write map, or it's better write position. We can simply write position of I equals to I. Okay, and after this loop we can write that position of 0 is 10. Okay, now till here we are clear, and we can have one variable answer and initialize it to 4. Why 4? Because we know that we will be printing this 4 numbers, so that will require 4 operations. Okay, now we know that we are at 1, then we can simply have a count like the previous character as 1, set as 1, and from this one we can keep on moving to the next character and can add their absolute differences as we discussed here, and then finally we can return that answer. Now let's move to the code. So if we'll move see the code, I'll just minimize it. So what we are doing is, we are just making a map. We are making a global map because it will be used in all test cases. So we are just making a global map and storing all the position, because position will always be the same. And now we take the input, what the pin we have to print. Initially we have our character as 1. I have taken this as string, because if we would have taken this as number, we'll have to find out the next number and we'll have to keep on dividing it. So it's better I took it as string. Previous character was 1, and we are just checking out what will be the next number. Like the first number we will be checking and comparing the distance or the absolute difference between their position and adding it to answer and updating my previous value, right? So for the first time the previous will be 1, then next the previous will be the first character, then again the previous will be second character, something like that. So in move in that direction, and finally we can print our answer. Okay, if we want, we can just try and test the solution. Let's go try to submit this. So it's an accepted solution. I hope everything will be clear in the solution. Let me know if you guys have any doubt on this question. Okay, now let's come to question number 2. Just give me a second, let me clear this out. Yeah, so now coming to question number 2, we'll read the question number 2. What it is saying, that we will have a string s and we can delete exactly k characters, or we have to remove exactly k characters from it, and the remaining string can be reordered, and we have to tell that if that reordered string can be a palindrome or not. So we have to just print yes or no, saying that if we have a given string, so we'll have a string s, so we'll have a string, okay, and we have, let's say s, and we have a number k. What we have to do is, and let's say its length is n, then k will always be less than n. Okay, this is given in the question. And what we have to do is, from this s we have to delete exactly k characters. So from s we have to delete exactly k characters, and then after deletion, whatever the string s, let's say it's converted to t. Okay, so whatever this t is, the t will be a string. Now we can rearrange all the characters of this t. So rearrange in the sense, let's say if after, let's say if s was something like this to us, okay, and k was 3, that means we will have to delete 3 characters, and we deleted this one, and this one. Then the remaining string can for us will be ABF AB, right? Sorry, I written it two times here. AB. Okay. Now we can rearrange it whatever we want in whatever manner we want. If we want to write something like that, A B B F, whatever, however we want to rearrange it, we can rearrange it. Now we have to tell that after removing this K characters, that is whenever we get this T, can this T be a palindrome? Like right here, we can see that if we rearrange it in something like this one, ABF BF, sorry, ABF BA. So this will be a palindrome, or we can simply write something like, we can also write something this ABFB. Okay, so this will also be a palindrome. So that's what we need to answer, that whether after removing exactly K characters, the remaining string can be a palindrome or not. Given that, we can rearrange it. Now, so let's say we have some characters. Okay, we have some characters. Let's say A is repeated sometimes, B is repeated sometimes, something like that. Now, if we want any string to be palindrome, if we want any string to be palindrome, what does that mean? What does that mean? That means all the characters should occur in pair. Listen carefully. What I'm saying is all the characters should occur in pair, except middle element can occur single time. Except middle element, all the elements should occur in pair. So that, because that's what palindrome is, right? Like if we will start from reading from starting and end, the end, the character should be same. So for all the characters which are not in the middle element, their count should be even, so that we can place them in both the side, right? So the question is now reduced to very simple. So like we have n characters, right? And we can remove k of them. We exactly k of them. Now let's say if I have all the numbers as even numbers, even in the sense ki their frequency is even. Let's say if A is occurring 4 times, B is occurring 6 times, C is occurring 0 times, and D is occurring 2 times, something like that. That means if all the frequencies are even, that means we can always have numbers in pairs, like A B B, like B was 4 times, so we can write something like this, or 6 times, so we can write B times on the left, 3 times on the right. So what it can do, it can help us in making a palindrome if it is all even. Now let's say if it is odd, or some digits are odd. Okay, or no, or before continuing to that, let's say if we want to remove exactly K characters. Okay, so if we want to remove exactly K characters, and we know that all occurs in pair, so it doesn't matter, we can start deleting from the middle or anywhere you want. If you want to delete this. So but whenever we will delete both the pair if possible. We will delete both the pair if K is greater than 2, let's say. Then we'll start deleting both the pair characters from the starting and the end. Okay, and then we'll K reduced by 2. Okay, then K will become K minus 2, and let's say it is still greater than 2. Okay, then we'll remove these characters from the start and end. Now at some point K either can be 0. Okay, if K is 0, then we don't need to do anything, and whatever the remaining string was, that will be palindrome, because it was already palindrome, right? Now let's say if in some cases K becomes 1, then what will happen? We know that whatever the remaining portion or the remaining string we have is a palindrome. And let's say whatever the numbers we have x over here, we know that ultimately this is a palindrome, and all the numbers were occurring in pairs, like the count or the frequency of all the numbers was already even. That means that means if we remove this one this x, then this x will be remaining, and we can put this x into the middle. Listen carefully what I'm trying to say. We already knew that everything we have is occurred in pair. Nothing was singular. So palindrome was something like this: x x, y y, z z, something like this, and there was nothing here. Okay, so it was even length. Now, if we remove just one character in this scenario, then also we can put this x in the middle, and we can split this palindrome, right? Because already see, what we had was, this was even length palindrome, or saying that all the characters were in even numbers. So this will also be, and this will also be, if we'll take this this will be a palindrome, right? And if we'll just split it, remove one x for this k and put this x in between, then also this part is here, this part is over here, and putting x over here, it will be in the middle, and this will still be palindrome. So what we realize from here is, if if all the numbers, if all the numbers are in pairs, are in pairs then are in pairs in the sense the count is even, count is even, then in that scenario it doesn't matter whether k is even, because it was getting to 0, that means k was even, right? Because we are subtracting 2 each time. So it was k was even or k was odd. In both the scenarios we have our solution, and we can simply return yes in those cases. Okay, I hope this was clear. So what we are saying is, if there was no odd count, no odd count, right? No odd count, then we can simply return yes. Now let's say if we calculated this frequency count for each character, like for A, B, and C, and let's say exactly one of them was odd. What I'm saying is exactly one of them was odd. Then in that scenario also we know that rest all are in pairs. So we can simply put them, and this can be put it over here. Right now we haven't deleted k characters, right? Okay, we have not deleted any character. So we know that there is only one odd. Then we can, what we can do is put all the remaining even characters on both the sides because they are in even in numbers, and we can put this odd character over here. Okay, it's not, I am not saying that there will be only one. I'm saying that the count will be odd. That means it can be 3 times, it can be 5 times, maybe it can be 1 times. So like if it's 3 times, we can put it one time in the left side, on one time on the right side, and one time in the center. So overall it will be odd. That's why we need to put one in center. Now if there were three such numbers whose frequency, or three such characters whose frequency was odd. Now we know that in a palindrome we can have only one character whose frequency can be odd. Okay, so that means we'll have to delete two characters. Now let's say if A frequency was 3, B frequency was 5, and C frequency was 7. So what I'm saying is, if we want, and rest other, we can consider that as they are even. Whatever the count was, they all were even. Now what I'm saying is, if we want to make a palindrome from these characters, we can have only one character which can have odd values. So if you want to make this even or this even, what we have to do is just delete one character. Just delete one character, or just delete one character. So from here what we can see is, at max what we can do is, we have to delete at max, like let's say here there were three three characters with even count, right? Three characters with, sorry, odd count, not even, odd frequency basically. So at least two of them needs to be deleted in such a way. We don't need to delete all the fives, we just need to delete one character or one repetition of B, such that it becomes 4, and that will be an even number. Okay, similarly for C we can just remove one C and it will become 6, which is an even number. Now so what we realize that we have to just delete all the characters, or like all the odd frequency characters, till there is only at max one character with odd frequency is left. That means we know that one more thing, that we can at max, or like we have to exactly delete k characters. Okay, now if the required, like let's say if we, there were d characters whose frequency was odd. Okay, and we know that at max we can have one, we can allow at least at max one character to have odd frequency. That means d minus 1 should be less than equal to k. Okay, because once it is a palindrome, once it's a palindrome, then we know that, right? We know that we can have our k characters, like we can have our k even and odd. So like coming back over here, we already see that, right? Like if k is, if all the numbers are even, or like also if we have some k in between, like just forgot to mention, I'll just repeat it over here, just a second. So we have already see that if all the numbers are even, right? All the numbers are even, that in that scenario if k is odd or even, doesn't matter, we can always have our answer as yes. So if let's say there was one x as well, so that frequency count is 1. So in that scenario also, like if it's even, we can remove from side or side, and if it's odd, we can remove this last character from here. So in all the scenario, if it's a palindrome, it's already a palindrome, then we can have any value of k, either it's even an odd, because we already know that, right, k will be less than n. So we are not going to delete enough characters, so we don't need to worry about that, whether it's whether there are characters or not. But if k is even or odd, that doesn't matter. If it's a palindrome, eventually it will be palindrome, right? So here we know that to make palindrome, there were d characters, right? There were d characters with odd count. Then we will have to eliminate at least d minus one of them, because one can be remain there. One can remain there. Okay. So now d minus one should be greater than, sorry, should be less than equal to k. That means d, or we can simply write that we can, first of all, what we can do is we can simply calculate this d value, and then we can check this condition. If it is true, then we can have our answer, else we won't have our answer. Okay, so coming to this code, sorry, this was the previous question code. Yeah, sorry. Sorry, this is the one, right? So what we did was, first of all, we taken the input s, and we created the frequency count. Now we know that if it's odd, then only we'll have to check it. Sorry. Huh. So what I was saying, that if it is odd, right? We have already saw that we need to calculate how many numbers are, how many characters are there with odd count, right? So we are checking that if its count is odd, then we are just incrementing p, and we know that p minus 1, what we were saying over there, we can simply write it as this also. p minus p minus 1 should be less than equal to k. That's what we discussed here, right? That d minus 1 should be less than equal to k. So we are counting here in the p variable. So if it is odd, we are simply incrementing it, and at the end, if it is less than equal to k, the answer will be yes, else it will be no. Let's go and try to solve submit the solution. Anyways, it will be an easy solution because I have already submitted it during the contest, but just for the sake of acceptance, we will resubmit it. Okay, so yeah, we can see that it's an AC solution. Okay, thank you guys. So this was question 1 and 2. We'll be soon uploading the question number 3rd and 4th as well, and rest of the question as well. Thank you guys.